All right, so last section we are going to take a look at in chapter 5. It's 5.5. Still on logs, but we're going to look at how we can sketch them. We're going to do a little bit with what's called the change of base formula, and then we'll finish up with a word problem. So there are only two bases that I've talked about so far that you can put in on the calculator just using a single button. Does anybody remember what those two bases are? Yep. And what's the base on log? Yep, 10. Yep, so common log. And what's the name of the other kind of log? Yep.
Isn't it natural log?
Natural log. And what's the base on that? Yep.
E.
E. So other than 10, base 10 or base E, we don't know how to put it in the calculator, or at least I haven't shown you how to do it. That's what this formula is going to do. So it allows us to put in a log that has any base. And there's actually two ways we can do it. So let's say that we had to figure out log base 4 of 13. Base 4 is not base 10, and it's not base E. So you can't just use the button directly to do it. But what you can do is write it as a fraction. You can write this as log over log. And it is important which number goes on the top. So if you look at these two numbers, the 13 and the 4, which one is higher? The 13. So because that one was higher, the 13 goes on the top. And what do we call 4? The base. And think of the base, like if you're looking at the base of something, the base is at the bottom. So 4 goes in the bottom. That's one way that you could type in log base 4 of 13. Use common log, or you could do it with natural log. Same thing, 13 in the top, 4 in the bottom. Okay. But I would just pick one way. Don't mix logs and ln's in the same fraction. Either do log or do ln. And when you type it in, it's going to open a parenthesis for you. You need to make sure you close it after the 13, and then we'll close it again after the 4. We did it with ln's. ln of 13 divided by ln of 4 comes out exactly the same. So now, if I took, that's 1.85. If I took 4 and raised it to the 1.85 power, what do you think I would get? 13. Yeah, roughly. 4 raised to the 1.85. I get 13. So that's an example of how to simplify a log that's not base 10 or base E. Any questions on that? It's called the change of base formula. Okay. So now we're going to use that formula to graph this. So it says find a complete graph and then determine the domain and the range. Okay. Well, first thing is that base, a base that we can plug in with a single, just using a button on the calculator. Did it check? No, that's base 3. We don't have a button for base 3. We have a button for base 10 and base E. So we need to rewrite that as a fraction. There's two ways. Let's just pick one way. Can somebody give me a way to rewrite that as a fraction? Yep.
Log x over log 3.
Sure. You do log x over log 3. And what base are you using on both of your logs now? 10. So we've changed the base in this problem to a base 10 problem instead of a base 3 problem. And we have a button for base 10. So now we can do. All right, let's put that in. So when you type it, log x, make sure you close your parenthesis. divided by log 3. Doesn't really matter as much if you close the second parenthesis, because there's nothing after it. But if you don't close the first one, it will be wrong. Let's do zoom 6. Let's look at the picture. And we did look at a picture on Monday, so we should have an idea of what it's supposed to look like. Is that a good sketch? What do you think?
I'd say it's all right.
Julia, what do you think?
Doesn't it go all the way down because maybe it messes it up?
Yeah, that's not a good sketch. The calculator cannot accurately sketch a log function. And can you say why? Again, what should be but it's not? It's supposed to keep going down because what do you have right on the y-axis? We have an asymptote, yes. This should keep going down like that. Okay, so that is what your sketch should look like. Great. What's the domain? Yeah, works.
Is it all real numbers?
No, log functions do not have a domain of all reals because you can never fill in a negative for the argument. Yeah?
Greater than 0?
Greater than 0. Yeah. And we don't reach 0 because it's a vertical asymptote. So it's everything greater than 0. How about the range? What's the range? Yes? So you're saying the graph goes down forever,
Yeah.
but it doesn't go up forever.
No. Oh,
Yeah, it's negative infinity to infinity because this part is just going to keep going like this. It doesn't go up very fast, but it does keep going up. So the range goes down forever, and it does keep going up forever. So that's how you can graph a log on the calculator that's not base 10 or base E. That's everything they want. Any questions on that? So let's look at transformations. Okay. Transformations are identical to every function that we've done all year. And on Monday, we already went through all the transformations in a lot of detail. We did it for exponentials. So I'll go through the transformations again. I'm not going to write as much detail as we did on Monday, but you basically can copy the chart from Monday. It's the same thing. Let's start with A. A is on the inside. And when I say inside, I mean in the parentheses. This is the argument. It's in the argument. What kind of transformation would adding or subtracting inside the argument be? Yep.
Horizontal shift.
That's a horizontal shift.
Is that plus or minus? Or
Yes.
is that underlying plus?
No, plus or minus.
And if you add, which way would that shift the graph? To the left, and if you subtract, to the right. So remember, horizontal is always backwards. Okay, so that's what A does. How about B? What kind of transformation is that? It's still on the inside, but now it's multiplying the x instead of adding or subtracting. Yep. Nope, not a vertical. Yeah. Horizontal. And what did you say? Horizontal stretch. Yes. Okay, so B is a horizontal stretch. What if B was 3? How would you describe that? Yep.
B stretches by a factor of 1/3.
Yes, it's horizontal stretch by 1/3. So if you make, the bigger you make B, the more squished it actually gets. What if B was a half? How would you describe the stretch now? B was 1/2, yep.
Stretching by a factor of 2.
Right, stretching by 2. So when you make B really, really small, it actually stretches the graph bigger. Yep. What else? If B is a negative number, what does that cause the graph to do? Yep.
Reflection of the y-axis.
Yep. B, if it's negative, is a horizontal reflection, which means your picture would flip left to right. That's over the y-axis. So that's B. All right, let's do C. Now we're on the outside of the argument, and we are multiplying. What does multiplying on the outside do? Yep.
Vertical stretch.
That's your vertical stretch. And there's nothing backwards. Okay. If C is 5, it's a vertical stretch by 5. If C is 1/3, it's a vertical stretch by 1/3. It's not backwards. What about if C was negative? What does that do? Yep.
Reflection of the x-axis.
Right. If C is negative, that's a vertical reflection, which means you'd have something like this. It flips up and down. That's over the x. Okay, and the last one is D. D is like A, it's adding and subtracting, but now it's on the outside. So what does D do? Yep.
Vertical shift.
Vertical shift. And if it's positive, it would shift it up, and negative
Down.
down. So again, for more detail on that, just look at the example from Monday, and that's got a lot of detail, but it's identical to this. All right, so let's try an example. It says, how can log base 3 of negative x be graphed from log base 3 of x? So this is like the parent function, and we're doing something to it. How many transformations are we doing to change this into that? Yep, just one. Yeah, there's only one transformation there. It's like having a -1 in front of the x. That's the only thing you're doing. Okay, so we'll describe the transformation, and then we'll find the domain, the range, and the asymptotes. Okay, so let's start out with describing the transformation. All right, so to graph. What is the negative in front of the x going to do? Yep.
Reflected over the y-axis.
Yep, reflect it over. Can you say it one more time?
The y-axis.
Yep. So to graph y equals log base 3 of negative x, reflect the original, y equals log base 3 of x over the y-axis. Okay, so there's the first part. Now they want the domain, the range, and the vertical asymptotes. Well, we just graphed log base 3 of x. That's the one that we just did right here. So let's take that picture again, and let's reflect it over the y-axis and see what it looks like. Remember, this part keeps coming down. If you reflect that over the y-axis, which way is it going to go horizontally now? It's going to go left instead of right. So it's going to look something like this. It's going to come up, curve. Well, it's not perfect, but you get the idea. Something like that. Okay, so that's the reflection. What is the, let's see, they want the domain. What's the domain of that graph in red? Yep.
0 to negative infinity?
So when you read, careful, when you say your domain or range, you have to give the low value, then the high value.
I said 0 to negative infinity to 0?
Negative infinity to 0. Yep. So the lowest it goes is negative infinity, and the highest it goes is 0. How about the range? Again, looking at the red one, that's the reflection. Yep.
All real numbers.
Yeah, you can't change the range of a log. It's always all real numbers. Doesn't matter how you stretch, flip, or reflect. It's always all real numbers. And what's the other thing they want to know? Vertical asymptote. Okay, when you write the equation of a vertical line, it starts out with what letter? X. And where would the vertical line be for the asymptote for the red graph? At what number? Yeah.
0.
0. Now, if you write it x equals 0, right here. It's actually the same asymptote for the red one and the blue one this time. Okay, so we've got domain, range, asymptote, and how to do the sketch. Any questions on that? All right, we're going to try another one with transformations. This time we'll have more than one. So when you have more than one, make sure you follow the order that's up here. Horizontal shift, horizontal stretch, horizontal reflection, vertical stretch, vertical reflection, vertical shift. That's the order of all 6. All right, let's try this one. How can you get log of 3 minus x from just log x? What's a little different about log 3 minus x? Yeah?
The negative x.
Okay, so can you explain more? What do you mean?
Are you comparing that to log x?
Well, we are going to compare it to log x, yeah. But I'm looking at the template I just gave you, and I'm looking at what they gave me. Yeah?
The vertical shift is a variable. Or never mind.
The vertical shift is a variable.
No, I meant horizontal shift, but I'm still wrong.
Any other thoughts? Yeah?
Or like E's and negative instead of X's.
The B is a what?
Like the 3 is a negative, but the negative's after the 3.
Okay, so could we fix that so it looks more like the template I gave you?
I don't know how, but probably.
Yep, we probably can. How could we fix that? So it matches exactly what's over that template. Yeah?
Negative x plus 3.
Yeah, let's make it negative x plus 3. Then it matches the pattern of the bx plus a. It's kind of like if you had to write an equation in y equals mx plus b form, like a line, and you wrote something like this. Well, that's not, I mean, it's close to mx plus b, but you should have written negative 4x plus 3. Okay, you should have put the x first. Okay, we'll do the same thing. Okay, how many transformations is it going to take to change log x into log negative x plus 3? Yep, 2. Can anyone tell me what the first transformation would be? Yeah.
Go left 3.
Yep, shift left 3 units. And the second transformation. Okay.
Horizontal stretch. Horizontal stretch.
In this case, there really isn't a horizontal stretch because the number in front of x is just a -1. Anytime it's a 1 or a -1, there is not a stretch. But what is that number doing? Yep.
Like the reflecting the graph over the y-axis.
Right, it's just causing a reflection. So reflect over the y-axis. Any question on that one? All right, so we're going to look at now doing a sketch by hand. And one of the most important things that we have to figure out when we sketch by hand is the asymptote. Because once you know that, you know your log function is always going to bend away from it. It's either going to bend to the right or it's going to bend to the left. But if you can't figure out that asymptote, you don't know where it's bending away from. So I'm going to show you how you do that. A couple other things that are helpful to find are the intercepts. Now, when you graph a log function, you're only guaranteed to have one of these intercepts. You could have both, but you're only guaranteed to have one. Which intercept are you guaranteed to have all of the time? Yep. The x, how come?
I don't know. I'm just thinking because after I saw all the graphs, you always crossing the x-axis.
You will always cross the x-axis. Can anybody give me a reason why? The graph always crosses the x-axis? Yeah?
Because there's always a continuous vertical line going through. Not. Because it approaches either infinity.
Well, okay, talk to me more about infinity.
Well, infinity is, so it's not like it, eventually will yeah. You know what I mean? Picking up what I'm putting down?
Kind of. Yeah.
It's because
Looking for something specific that we've said today.
the range is all real numbers, and
Yes.
so eventually, at some point, like he was saying, it will cross the x-axis because
Yeah.
it's every single number.
Right, the range is all real numbers, which means the graph goes up forever and it goes down forever, and it is always connected as it does that. So yeah, as we were saying, your range goes up and down forever, so it will hit the x-axis at some point. You're not guaranteed to hit the y-axis. Just go back and look at the picture right here. These graphs never crossed the y-axis because they had a vertical asymptote right on the y-axis. Okay, so how do you find the new vertical asymptote? Well, if you shift the graph left or right, or you flip it, it's not going to be x equals 0 anymore. The way that you find the new asymptote is you set your argument, which is what's inside the parentheses, equal to 0, and you solve it. Nothing on the outside of the parentheses matters when you are trying to find the vertical asymptote. Doesn't affect anything. Think about a vertical line. It goes up and down forever. If you shifted it up or down, it would still go up and down here. So we don't have to worry about anything on the outside of the argument. Just set the argument equal to 0 and solve. And just a reminder, when you are looking for the x-intercept, that's when you plug 0 in for y. And when you're trying to find the y-intercept, you plug 0 in for x. Remember this one you are guaranteed to always have it. So you should always find it. Y-intercept depends. You might not have a y-intercept. Okay, but the first one that I give you, it will have both intercepts, so we'll be able to do both. Okay. If you feel like you need a few more points, which you probably will, you'll need probably 2 or 3 points to do a log function, because you gotta be able to draw the curve. Okay? So what we'll do is we'll use the table to get some more points. But remember, once you have your asymptote, the graph only bends in one direction. If you pick points that go the wrong way, okay, let's look at this one. Let's pick some points over here. The graph doesn't go over here. So what do you think is going to happen in the table? Yeah, I'm going to get errors if I pick negative numbers. I'll be okay if I pick positives, because that's the way that it goes. But I can't pick any negatives, because that's the wrong way. Okay, so you've got to pick points that go in the direction your graph is bending. It could be right, could be left. It depends on the graph. All right, so let's try to sketch this one. So y equals, or g of x equals log base 2 of 3x plus 5. Okay, so we'll do that sketch, and then we'll find the domain, range, and asymptotes. We need the asymptote anyway to do the sketch, so that's not really any extra work. We don't need the domain and the range to do a sketch, so it's a little bit extra work. Okay, let's start with the vertical asymptote. Can somebody tell me the equation that I'm going to set up and then solve to get the vertical asymptote? Yeah?
Would be 3x plus 5 equals 0.
Set the argument equal to 0 and solve. So we get 3x equals negative 5. Or as a fraction, x equals negative 5/3. It's going to be helpful to know the decimal when I graph that. What's negative 5/3 as a decimal?
0.6.
Yeah, it's 1.6 repeating.
Huh?
It's 1.6 repeating.
1.6 repeating?
Negative 1.6.
Negative 1.6.
Yeah.
So let's put in a vertical asymptote. We'll do that. Negative 1.6. Maybe about right there. Okay, so I got my vertical asymptote. Now the graph is going to do one of two things. It's going to bend away from it, either to the left or to the right. All right, let's do the y-intercept. Okay, y-intercept is when you plug in what number? 0 for what letter? X. Okay, let's do that. Plug in 0 for x. So fill 0 in right there. So we're going to have y equals log base 2 of, and then fill in 0 for x. What's 3 times 0? Plus 5. 5. How am I going to type that in on the calculator? Yeah?
Log 5 over log 2.
Log 5 over log 2. Perfect. So my y-intercept is about 2.32. Okay, I've got enough information now that I know which way the graph is which way it's bending. Is this going to be bending to the right or to the left of the dotted line?
Right.
To the right. Yeah, I can't cross that dotted line. I already have a point on the right side of it, so it's got to do something kind of like that. I want to get a little better sketch, but that's the idea. Okay, let's find the x-intercept. Okay, how do we find the x-intercept? Yeah.
Set y equals 0.
Set y equal to 0. So we're going to have 0 equals log base 2 of 3x plus 5. And what can we do with that equation? Yeah.
Do we rewrite it?
How would you rewrite it?
Log 3x plus 5 over log 2.
So doing that kind of rewrite, well, not incorrect, won't help us a ton. We need to rewrite it in a different way that we talked about yesterday.
Oh,
We have to put an exponential form.
Put that in exponential form. And can you put that in exponential for me?
Would that be 2 to the power of 0 equals 3x plus 5?
Yep. So that's rewriting it in exponential form. And 2 to the power of 0 gives us 1. Subtract your 5. You get negative 4 equals 3x. So x equals
Negative 3/4.
-4/3. So negative 1.3. Repeat. That's your x-intercept. So that's about right there. Okay, so we've got 2 points. We can see a little bit of the curve, but we need maybe 2 more x values in that area. What would be 2 other x values that would be good to plug in?
7.
3 and 7? Sure, yeah, we could do 3 and 7. We got to make sure we have our problem in there. We don't. I'm going to put it in there the way River just said, though, with the change of base formula. So 3x plus 5 divided by log 2. Okay, so you said 3 and 7. All right, so ignore the negatives. Those are from a different problem. We can't use them anyway. So 3, we're at just under 4. This 3, about right there. And then 7, we are a little bit under 5. About right there. Oh, that's pretty good. So now just draw your sketch. All right. Any question on that? And now they want the domain range. We already have the asymptote, so that's done. What's the domain here? Yeah?
-1 point. Right.
Can you give me the number you're thinking of as an exact answer?
Oh, negative 5/3
Okay.
to infinity.
Infinity. Including or not including negative 5/3?
Not including.
Not including. Yep. So it's everything from the asymptote to the right. That's your domain. And what about your range? Yep.
It's all real numbers.
It's always all real numbers. Range can never change.
And also, for the domain, should you write it as a fraction like that?
Yeah.
Instead of the 1.6 repeated?
Yeah. Because in Edgelast, to do the repeating symbol, usually you put a bar above the number. I don't think there's a symbol available to do that, at least that I have for you to use. So yeah, you just do it as a fraction. All right, so domain, range, asymptotes, and a sketch. All right, any question on that? All right, last question. So the last question is a word problem, and it uses a formula to figure out what's called the magnitude of an earthquake. So if you hear about an earthquake like on TV and it says it was a magnitude 4.6, that's the formula that they use to figure it out. So the number that you hear about when they report about an earthquake, that's called the magnitude. There are 3 variables in the formula that go into figuring that magnitude out. A, T, and B. A is measuring the movement of the ground. Okay, it's measuring it in micrometers. Okay, that's very small. A micrometer is 1/1000th of a millimeter. So it's very small.
Is that a plus B?
What's that?
Is that a plus B?
Plus B, yeah. T is measuring what we call the period of the wave. Right? If you think about like dropping a rock in a pond, when you drop that rock, you get a wave that comes out from the center. Well, the same thing happens in an earthquake. There's a wave that comes out from the center of the earthquake. The best way to describe the period is pretend like you were standing like at the beach. You're counting how many seconds between the waves coming in. However much time it takes for the next wave to come in, that's the period of the wave. It's how often the waves are coming. So if the period is really short, that means waves are coming in fast. That's going to cause more damage. If the period is really long, like a minute, that means you're only getting one wave every minute. That's a lot slower. That's less damage. Okay, so how often the waves from the earthquake are hitting you, that controls it. And the last thing that affects the earthquake is B, which is a factor that accounts for the weakening of a wave. If you take the same size object and drop it in water and then drop it in a pile of sand, well, you drop it in the sand is going to absorb the energy because the sand is all loosely packed. So you'll get a wave, but it might only come out like a foot if you drop a pretty small object. Versus if you drop it in water, that wave just keeps going for a long time. It takes a really long time for the wave to dissipate. And that's what B is. Okay, so any question on the formula or the variables that go into it? So I'm going to give you some information, and I just want you to calculate the intensity of the earthquake. Okay. All right, so we have the following measurements. Let's say A is 200. T T is 3 seconds. So there's a wave from the earthquake coming every 3 seconds. And B is 3.55. The higher that B is, the worse the earthquake is. The lower B is, the less damage the earthquake causes. So you want a low B value. It's kind of a moderate B value. It's kind of in the middle. All right, so we have the following. So I want you to calculate the intensity of the earthquake. Calculate the intensity of the earthquake. Okay, so first thing that we need is to fill everything into the formula. What's it going to look like when we fill in our 3 values into the formula? Yeah.
R equals log parentheses 200 over 3 parentheses plus 3.55.
3.55. So yeah, we just have to fill that in, and that will tell us the intensity of the earthquake. So it's log 200 over 3 plus 3.55. That would be a magnitude 5.37 earthquake. In terms of earthquakes, 5.37 earthquake, it would be moderate. You would definitely feel that. Could cause some damage, but it's nowhere near like a magnitude 8 or 9.
Isn't an exponential scale?
Yeah, so the way that earthquakes work, if you have a magnitude 2 earthquake versus a magnitude 3 earthquake, the magnitude 3 is 10 times the intensity of a 2. Yeah. And if you had a magnitude 2 versus a magnitude 4 is 100 times a magnitude 2. It's the same way pH works in temperature. Yep. Good. So any questions on that? Okay. All right, so we did not do 5-4 part 2. So that is the homework for tonight. And I already have the list of topics, so I'm going to just paste those into the video right now.